Structure determines property. Structure is the key to everything in chemistry. The properties of a substance depend on the atoms it contains, and the way these atoms are connected. This video will begin to let you understand the relationship between structure and properties in organic compounds. So let's begin to talk about the actual chemistry with the atomic number. Z. So this number is unique to each element. So every atoms or every element, carbons, hydrogen, oxygen, they all have different atomic number. And in neutral, or a neutral atom has atomic number that is also is equal to the number of electrons. And another important thing that you may review is a valence shell. That especially in the second row elements where there are no d shells yet, the valence shell electron or the valence shell is always 8. For all second row elements. Atoms combine with another to give compounds. And the attractive force to make compounds between atoms in a compound is chemical bond. One of the type is ionic bond. It's one of the type of the chemical bond, and it's a force between attractive force between negatively charged anion and positively charged cation. And one of the example is Cl plus B minus becomes Cl minus, and Na becomes plus Na plus E minus. So in the top case, or V Na plus, we both call these as ion. And when an atom forms ion, they will either release or observe an energy, and these energies are called ionization energy. So when chlorine becomes chloride ion, it releases energy, and in this case we call it an exergonic or the sodium atom becomes sodium ion, it absorbs energy, and it's endergonic. So how much energy the chlorine releases when it becomes an ion is about negative 349 kilojoules per mole. And sodium ionization energy is 496 kilojoules per mole. So Cl plus Na becomes NaCl. If you add these two energy, it's a positive number around about 147 kilojoules per mole, and it is not a spontaneous reaction. But here what we have is called lattice energy. So let's talk about this lattice energy. Lattice energy is a form of the attraction or energy release in the formation of solid ionic compound, or not necessarily solid ionic compound, and that depends on what kind of ion or compound is made from third ionic bond. In this case, the lattice energy for Cl plus Na becomes NaCl, or more likely Na plus Cl minus becomes NaCl. The lattice energy is 787 kilojoules, negative 787 kilojoules per mole, and which is much more than it is required. So the forces between oppositely charged particles are called electrostatic or Coulombic. And one more important thing, when Cl wants to be ionized to be Cl minus. The energy released was negative 349 kilojoules per mole, and this number right here is sometimes referred as electron affinity. So more negatively the number is bigger, the more like higher electron affinity the atom or the element has. So let's do some example problems. Example 1. How many electrons does carbon have? How many are valence electrons? What third row element has the same number of valence electrons as carbon? So the number of electrons in an element is equal to the number of protons in its nucleus. And Z number for carbon. So Z for carbon is equal to 6. Therefore, carbon has 6 electrons. Of these, it has 2s, 2 and 2p, 2 electrons, so total 4 valence electrons. If you see a periodic table under carbon, there will be silicon, and if they are on the same column and the column represent the same group number, they are in group 4A, and this represents that the silicon has also 4 valence electrons. So answer to this will be silicon, and answer to this will be 6 electrons and 4 valence electrons here. Referring to the periodic table as needed, what write electron configurations for the first and the last element in the third period? The first element is Na, and Z is equal to 11. And the last one is argon, then Z number is equal to 18. So starting from 1s2, 2s2, this is equal to 4 so far, and 2p6, so this is 10, and 3s1s, total 11. This is the electron configuration for Na. And for argon, it will be almost the same, and keep going to 3p6. And sometimes you can specify this as 3px2, 3py2, and 3pz2, total add up to 6 as well. Example 3. Species that have the same number of electrons are described as isoelectric. Same number of electrons. So what plus 2 ion is isoelectric with Na plus. Na from the previous problem we know has a Z number of 11, and Na plus will have 11 protons and 10 electrons. I'm going to abbreviate it as E minus from now on. So you're looking for the plus 2 ion that has 10 electrons. So in order to be plus 2 that has 10 electrons, it must have 12 protons. And an atom that has 12 protons, which means Z number is equal to 12, will be magnesium. So Mg2 plus magnesium ion will be an isoelectric with Na plus, and minus 2, so 10 electrons with 8 protons will give -2 charge, and an atom that has C number is equal to 8 will be oxygen. So answer will be magnesium 2 plus 4 plus 2 ion, and oxygen ion 4 -2 ion. Example 4. Which of the following ion possesses a noble gas configuration? So K plus has K, the Z number for K is 19. And if you look for the noble gases, and K plus will have 18 electrons, then an atom that has 2, which is helium. Let's go to the periodic table shortly. Helium, the next one is going to be neon that has 10 electrons, argon that has 18 electrons, and krypton that has 36 electrons. These are going to be considered noble gases. And K, we see 18 electrons matches to argon, so A is definitely one of them. Hydrogen ion with a negative charge has 2 electrons. So yes, it is. And fluorine with negative will be also 18. So it is. Helium will not have, helium positive ion will have 1 electron, and that does not equal to 2 electrons. Oxygen with negative will be 9 electrons, and that is not equal to 10, so it doesn't count. Calcium with 2 positive charge will have 18 electrons, which matches to argon, so it does have noble gas electron configuration. Example 5. What is the electron configuration of C plus and C minus? So does either one of these ions have a noble gas electron configuration? C has 1s2, 2s2, and 2p2. So C plus will then be 1s2, 2s2, and 2p1, which does not have 8 valence electrons, so it doesn't. Or C minus has 3. This one also does not have valence electrons, so neither one, or doesn't have 8 valence electrons. So neither one will be considered as a noble gas electron configuration. Example 6. Write Lewis formulas including unshared pairs for each of the following. Carbon has, or the following compounds are A, propane, C3H8. So propane has C, 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 H, H, H. As you see, the first carbon has 1, 2, 3, 4 bondings, and second carbon has 1, 2, 3, 4, and the third carbon has 1, 2, 3, 4, and H's, and it has all shared electrons and no more unshared electrons. B. Methyl fluoride, CH3F, CC, or methyl. So C with 4 bondings, that has 3 H's, and F has 3 or 6 unshared electrons, so 3 unshared pairs. C, methanol, CH4O, methanol. C with 4 bondings, each will have H, and O with H with 2 unshared pairs. And lastly, D, ethyl fluoride, C with C, and each C must have 4 bondings, and these will be filled with 5 H's and 1 F with unshared pairs.